Hi students, I am Bincy. Welcome to Bincy's class. Today we are going to see some important numericals from our first chapter, force. So before starting our numericals, it is very important to learn the formulae related to that. So let us see that first. Moment of force is equal to force into perpendicular distance. That is the first thing we have to learn. Next, moment of couple is equal to either force into couple arm. That is force into distance. So here what is couple? Two equal and opposite parallel forces acting at different points. That forms a couple. And couple arm is the distance between two forces. Okay, so force into couple arm you get for moment of couple. Next is principle of moments. In equilibrium, anti-clockwise moments equal to clockwise moments, or sum of anti-clockwise moments equal to sum of clockwise moments in equilibrium. So the formula will be in equilibrium W1L1 equal to W2L2. And one more important thing is anti-clockwise moments are considered as positive and clockwise moment is taken as negative. Okay. So what is clockwise and anti-clockwise moment? It is very easy to understand. Suppose a pivoted point is here and a meter rule or any object is there. If a force is acting in this direction, downward direction here, if it is acting, it will turn in this way. Isn't it? If the turning is in clockwise direction, we call this moment of force is clockwise moments. If the turning effect is in anti-clockwise direction, we tell the moment of force is anti-clockwise. Suppose here, this turns this force, if suppose 10 Newton force is acting at this point, it is turning the meter rule in anti-clockwise direction. Then the moment of force is anti-clockwise, and anti-clockwise moment is taken positive, clockwise moment is taken negative. Let us discuss some important questions from this chapter. First one, a half meter rod is pivoted at the center with two weights of 20 GF and 12 GF suspended at a perpendicular distance of 6 cm and 10 cm from the pivot respectively as shown below. Diagram is given here. And first one, which of the two forces acting on the rigid rod causes clockwise moment? So here from this question we can see one is, this is 12 GF, it turns clockwise, and 20 GF turns the meter rule anti-clockwise. Okay, so here 12 GF, first answer is 12 GF force turns the half meter rule clockwise direction. Okay, second question is the rod in equilibrium? So we have to check whether clockwise moments equal to anti-clockwise moments. Only then we can tell it is in equilibrium. So here if we check clockwise moments and anti-clockwise moments, we have to check. What is clockwise moments here? Clockwise moments equal to force into perpendicular distance. You get 12 into 10, 120 GF centimeter. And anti-clockwise moments also we will get. We have to check here force into perpendicular distance. Force is 20 into perpendicular distance is 6. So we get it as 120 GF centimeter. Since clockwise moments equal to anti-clockwise moments, we can tell this is in equilibrium. Okay. Now, third question is, this is the second part. Third part of this question is, if this 20 GF force is reversed, what will be the resultant moment of forces? That means this 20 GF force was acting downward direction. Now we have to change its direction. In the same position it is acting upward. Okay. 20 GF. Okay. So here as it is turning upward, that means This makes the half meter rule to turn again in clockwise direction. Both the forces turning the half meter rule in clockwise direction. So we have to add these. Okay. So total moment of forces or algebraic moment of forces will be 120 GF, that is due to this 20 GF. Okay. And plus 120 GF, both are clockwise, so we can write 240 GF centimeter. Here also centimeter should be the GF centimeter. So both the forces are turning the half meter rule in clockwise direction, so we get it as 240 GF centimeter clockwise. So total moment of force is 240 GF centimeter clockwise or minus 240 GF centimeter, we can tell, because clockwise moments are considered as negative. This question is from 2018 paper and it is 3-mark question. Now our second question is, two forces each of 5 Newton act vertically upwards and downwards respectively on the two ends of a uniform meter rule which is placed at its midpoint as shown in the diagram. Determine the magnitude of the resultant moment of these forces about the midpoint. And diagram is here. It is 1 meter rule, 5 Newton acting downward and here 5 Newton acting upward, and it is pivoted at 50 centimeter. This is our question. This question also is a board exam question. It is asked in 2014 and it is for 3 mark. Now from this figure we can understand this forms a couple. Equal forces 5 Newton acting opposite direction, and these two forces are parallel also. So moment of couple is equal to force into couple arm. So 5 Newton into, what is the distance between two forces? It is meter rule, so 1 meter. So we get the answer as 5 Newton meter. So our answer is 5 Newton meter. In which direction we have to mention. Okay. So this is anti-clockwise. This also turns anti-clockwise, and total is 5 Newton meter. We got anti-clockwise. We have to mention which moment of force is clockwise or anti-clockwise with the answer. Okay. So if we mention this, it is 3 mark question. We will be getting 3 mark. Next is a question from 2012 paper. A boy of mass 30 kg is sitting at a distance of 2 meter from the middle of a seesaw. Where should a boy of mass 40 kg sit so as to balance the seesaw? It is for 2 mark. So a boy of mass 30 kg is sitting at a distance of 2 meter from the middle of a seesaw. Suppose this is a seesaw. This is its center. Okay, I am taking it as O. Where the boy is sitting 30 kg at a distance of 2 meter from the middle. Okay. So suppose this boy is sitting 30 kg is his mass. He is sitting at 2 meter distance. Okay. Where should a boy of mass 40 kg sit so as to balance the seesaw? So somewhere this side. To ensure that this side somewhere 40 kg we have to place, and this distance we have to find, so we have to mark it as x, unknown. Okay. Now we have to use principle of moments here. What is it? Moments due to 40 kg boy is equal to moments due to 30 kg boy. That means W1 into L1 equal to W2 into L2. Moments due to 40 kg boy, 40 into distance x is equal to 30 into 2. Solve for x. 30 into 2 by 40. 0, 0 cancel. 2 1s are, 2 2s are. 3 by 2, that is 1.5 meter. So the buoy of mass 40 kg should sit at 1.5 meter from the middle of the seesaw. So we will get 2 marks for this. 1 mark for this substitution, 1 mark for the correct answer. Our next question is from 2011 paper. A uniform meter scale can be balanced at the 70 centimeter mark when a mass of 0.05 kg is hung from the 94 centimeter mark. Draw a diagram of the arrangement. That is the first part. Let us draw the diagram. A uniform meter scale. So, meter scale should be 1 meter. So, we will mark 0 and this side 100 centimeter. Okay. So, when you get a question, listen and understand it is meter or half meter. Half meter means we have to take only 50 centimeter. Scale can be balanced at 70 centimeter mark. 70 centimeter mark. So, somewhere in between 50 will come. 70 centimeter we have to balance. Okay. 70 centimeter mark. When a mass of 0.05 kg is hung from the 94 centimeter mark. So, at 94 centimeter, we are supposed to have 0.05 kg mass. Okay. Draw a diagram of the arrangement. So, this much things are given, but if you draw this diagram, you will not get the mark. Because we have to mark an important thing here, that is mass of the meter rule. Mass of the meter rule, we have to take, it is acting at its center of gravity. That means at the center, at 50 centimeter, we have to consider the mass. Okay, m kg we can take, or W is equal to mg also. Okay, mass, since here it is given in as mass of the meter rule is considered at the center. This is an important thing. If you don't mark this, we are not getting that mark at all. Okay, so whatever is given we have to mark, and at the center we have to consider mass of the meter scale or weight of the meter scale. Okay, so this is our first part diagram. For this diagram 1 mark we will get. Next one is find the mass of the meter scale. Find the mass of the meter scale. That is our next question. Find the mass. How can we find the mass? Here again we have to use our principle of moments. Okay. So W1 into L1 equal to W2 into L2 in equilibrium. But they have given it is in equilibrium. So easily we can mark this. Here weight is mg. M. G also we can take, no problem, mg into length. What is the distance between these two? From the pivot to the mass. 70 minus 50 is equal to W2 we can take as 0.05 G. Okay, because this is mass, so weight will be into G into distance between that 94 minus 70. From the pivoted point to the weight. Okay, so m, g and g we can cancel here itself. M into 20 is equal to 0.05 into 24. So m is equal to 0.05 into 24 by 20. Okay, we can cancel it. We will get here 12 and 10. Multiply. How much we get? Here we will get 12 5s are 60 and 2 decimal is there. By 10 also we get, isn't it? So 0.06 kg. This will be the mass of meter scale. So here For this substitution you will get 1 mark, and for this answer also you will get the mark. It is a 4 mark question. Our next question is from 2019 question paper. A uniform meter scale is in equilibrium as shown in the diagram. Diagram is given here. First question, calculate the weight of the meter scale. We have to find weight of the meter scale. They have given this much in the diagram. So in the previous question also I told you where the weight will be. It will be at the center of gravity. That means at 50 centimeter we have to consider the weight W. Okay. Then we have to take principle of moments. Apply principle of moments. In equilibrium, W1 into L1 is equal to W2 into L2. So W1, if you consider this, 40 into this distance. How much is the distance between them? 30 minus 5 is equal to W2. That is W into this distance. 50 minus 30. We should not take only 50 or here only 5. Here 30 minus 5. From the pivoted point to the weight, how much is the distance that we have to take? That means 40 into 25 is equal to W into 20. Therefore, W is equal to 40 into 25 by 20. So cancel 0, 0. 2 ones are, 2 2s are. We will get 50 GF is the weight of the meter rule. Okay. Now second part of this question is, which of the following option is correct to keep the ruler in equilibrium when 40 GF weight is shifted to 0 centimeter mark? If the question is 40 GF weight is shifted to 0. It is moved here, okay, to 0. Which statement is true? The statements are F is shifted towards 0 or F is shifted towards 100 centimeter. Which statement is going to be true? That means 40 GF moved towards 0. Okay, then what we have to move? Where we have to move? F. F we have to shift towards this side or towards 100. That is the question. So to balance this, since this length is becoming more, this length also we have to increase, isn't it? So we have to move F towards 0. That means second part answer can be F is shifted towards 0 centimeter. It is 3 mark question. 1 mark for the substitution, 1 mark for this answer, and for the second part 1 more mark. Total 3 mark. So what I want to tell you is, if you learn or practice these numericals, this is the maximum possible questions from this part. Okay. So if you know these 5 questions, how you can solve these numericals, you can do any numericals from this chapter. Please like and share this video. Don't forget to subscribe. Who did not subscribe still, please subscribe now itself. Then press the bell button. Keep the all option on. Only then you will get notifications for next videos. Thank you. See you in next video.